Hello, this is lab number 1 on charged objects presented by Team 4. So we know the fundamental concepts in physics, the electric charge, and since our very first science classes, we've learned about positive and negative charges, but how exactly do they behave? And more importantly, how can we observe them right here in the lab? So in this report, we'll step away from numbers and formulas and focus more on the observations using the simple everyday transparent tape. So by charging tape through contact and separation, we'll watch as the objects suddenly gain the power to attract, repel, or even discharge. And we'll demonstrate 4 key parts during this report. So first is how a single piece of tape behaves when charged. Second, what happens when 2 equally charged tapes interact. And third, how separating top and bottom tapes creates the opposite charges. And finally, what happens when those opposites are brought back together. So each of these interactions will help us better understand the rules of repulsion, attraction, and neutrality. So because the tapes have the same charge, they will repel each other. They will also be attracted to neutral and positively charged objects. So the tape and finger will be attracted due to having opposite charges. If the tape was negatively charged, they would repel each other. If the tape is neutral, it would still be attracted to a charged object. So yeah.
Now that we know the fundamentals of charge and how an object can acquire it, in this lab our goal is to demonstrate the different interactions of charged objects. This can be done utilizing simple household items such as a balloon in your hair, rubbing your socks on carpet flooring are a few examples of what can be achieved at home. However, for this lab, we will use a ruler to measure out the length of transparent tape and place those pieces along the edge of a table. Lastly, we will need a marker to label the pieces of tape accordingly. Before the procedure is explained, it is important to make scientific predictions of what we think might happen based on the knowledge that we know about charge and its properties. We will have 2 hypotheses. When the tape is charged, it will gain electrons and emit an attractive force. This will attract objects that are neutral or objects that hold no charge. And 2, when a charged tape interacts with another object that is also negatively charged, it will emit a repulsive force. Given what we know about charge and how it functions, it is safe to say we expect a charged object to attract a neutral object, even if it lacks a charge. However, if we were to place 2 negatively charged objects near each other, it is safe to say that they will repel each other. Now that we have gone over the basics of charge, the materials we will use to demonstrate charge, and 2 hypotheses as our testable statements based on the phenomenon, we can now go through the process of the demonstration to display the wonders of this underlying force.
For the procedure part of our experiment, we followed 4 separate sections labeled Part A, B, C, and D. So for Part A, we first measured 40 to 60 centimeters of tape and laid it down on the table. And then to charge the tape, we peeled the tape off quick. We wrote our predictions down beforehand so we could compare with the results. And then afterwards, we documented our interaction between the tape and our fingers. And then once we were done, we ran our fingers along the tape in order to remove the charge off. For Part B, we used 2 pieces of tape in a similar fashion to the one in Part A and placed it on the edge instead of flat out on the table after giving it a charge to use the second piece of tape to test its charge by holding it near the first piece but not allowing them to touch. For Part C, we used a single piece of tape and 2 non-charged pieces, and we put them flat on the table, and we labeled the 2 non-charged ones T and B for top and bottom so we knew which side to stick them together. Then after that, we peel them away from each other and test their charge with the charged piece of tape we prepared earlier. And then we removed the charge and then put them next to each other to test the interaction. And lastly, for Part D, we stuck the same 2 tapes together to then take them apart and watch their interaction.
For the data portion of this experiment, what we collected wasn't numbers, charts, or measurements. Instead, all of our data came from what we directly observed when we charged the tape and tested its interactions. So what I'm showing here is more descriptive rather than mathematical, but this tells us a lot about how the charges behave. So I'll talk a little bit about the experiments themselves. So in part A, we peeled a single piece of tape off the table, and right away we noticed it was attracted to things like a finger or even other neutral objects when we brought them close. But as soon as we touched the tape to discharge it, that attraction went away completely. This was the first clear sign that the tape had gained a charge through the simple act of peeling it from the surface, and that discharge could remove it. Moving on to part B, I repeated the process, but this time compared to two charge tapes. When we held them near each other, they repelled, and this was really different from part A because instead of pulling towards something, now they pushed away. That told us that both pieces must have gained the same type of charge. Since we know like charges repel, it confirmed that the peeling process was giving both tapes similar charges. And in part C, so we created two new tapes, which we called top and bottom, and we peeled them apart, and when we compared these to the original charge tape, the top tape repelled the original, while the bottom tape was attracted to it. And when we brought top and bottom together, they repelled each other, and this showed that separating the two created opposite charges, one positive and one negative, so their interactions were different depending on what they were tested against. And finally, in part D, we pressed top and bottom back together in their original alignment, and this time when we tested the combination, it behaved neutrally and there wasn't any strong attraction or repulsion. So that made sense because the opposite charges canceled each other out. And all of these observations are essentially summarized in the table down below, and you can see each part of the experiment listed with the setup, what we saw, and the interpretation of what that behavior means in terms of the charges. Moving on to the next slide, data analysis. So now we step back and kind of look at the bigger picture. So these observations all line up with the basic rules of charge interaction that we've been learning about in lecture as well. So charged objects will always attract neutral ones, and that's why the tape in part A pulled toward a finger or object before it was discharged. Like charges repel, and that was clear in part B when two equally charged tapes pushed away from each other. Opposite charges attract. This was shown in part C, demonstrated that when the bottom tape was pulled toward the original, and when you combine opposite charges, they cancel out. And that's exactly what happened in part D when the top and bottom tapes were pressed back together. So even though this lab didn't give us any numerical data, it gave us strong qualitative evidence. Just from observing, we could see that charges were being created by contact and separation, and that their interactions followed predictable, consistent rules.
In conclusion, the primary focus of the lab experiment was to gain a hands-on understanding of electrostatistics. Using simple materials, tape, a ruler, the edge of a tabletop, and a marker to distinguish the top and bottom pieces, we observed how positive and negative charges interact. Although electric fields are invisible, their effects become apparent through the attraction and repulsion between charged objects. Throughout 4 different test runs with the tape, we were able to clearly observe both attractive and repulsive forces, demonstrating key principles of electrostatic behavior. These observations not only reinforced our understanding of electrostatic principles, but also demonstrated how simple experiments can reveal the fundamental forces at work in everyday materials. By observing how the charged pieces of tape behaved in response to each other, we gained a better understanding of fundamental concepts like charge polarity, field interaction, and the behavior of non-contact forces. Overall, the activity made the abstract nature of electrostatics more concrete and highlighted the value of experimental learning in deepening our grasp of physical science. Lastly, if you have any questions, we'll be glad to answer. any that you may have. And thank you again for your time and going through our report.